Hey guys, today we're going to talk about finding the volume of prisms and cylinders. First thing we need to know is volume. Volume is the amount of cubic units it takes to fill up a 3D object. So the units we're going to use are always cubic units. The formula, there are many formulas, but there's one big generic formula. And to find the volume of any prism, we're going to multiply the area of the base shape, which is capital B in this circumstance, times the height of the prism. So when you're looking at a 3D object, you really need to know what the base shape is. That all goes back to what the name of the shape is. So all of those things tie together to help us figure out where to go and how to find volume. Some more specific formulas that the kids are probably more familiar with are so. Rectangular prisms, to find the volume, we just multiply length times width times height. Where we get that formula is based off the generic formula. I've underlined L times W in this circumstance because the base of a rectangular prism is a rectangle. So to find the area of a rectangle, we would multiply length times width. So that, in this circumstance, is represented here in the generic formula as capital B, or big B. So for triangular prisms, we would multiply half times base times height times the height of the prism. So I underlined this half times base times height. I put it in parentheses to show you that that is how you find the area of the triangle. The triangle is the base shape of the triangular prism. To find volume, we just multiply the area of the base shape times how tall it is. Does that all, I hope that all that comes together for you. It's all linked. So this H and this H are actually going to be two different edges of your prism. This H is for the triangular base. This H is for how tall the prism is. And we'll look at some examples in a second. Cylinders use the formula pi r squared times h. Again, the base of a cylinder is a circle. The area for a circle, the area formula for a circle is pi r squared. See where it's all coming together? Because we need to find the area of the base and multiply it by how tall the shape is, or the prism is. So we've got some rectangular prisms here. I've got a cube and then two other different looking rectangular prisms. The cube, what's special about the cube is all the side lengths are the same length. So in this picture, I highlighted the base for you. It's a square, and you only really need to know one side length because they're all the same number. So in this case, to find the volume of the cube, I would multiply the area of the base times how tall it is. Like I said, all of the edges here are all the same number, 6, 6, 6, 6, 6, 6. All of the edges are the same number. So instead of multiplying 6 times 6 times 6, I can shorten that mathematically and just represent it as one of the 6's cubed. That means 6 times itself 3 times. So in my calculator, all I have to do is hit 6 and raise it to the third power, and that's so much easier than typing 6 times 6 times 6. And that's a little bit less calculation on our part. And we'll get the volume to be 216 cubic centimeters. Again, with our units ending in cubic units, cubic centimeters in this case. I've got two different rectangular prisms. One is shorter and wider, the other one's taller and skinnier. This one kind of looks like maybe a tissue box, this one more like a cereal box. We're finding the volume, so the amount of space it takes to, or the amount of cubic units it takes to fill the space. I can use the generic formula, capital B times little h. Capital B stands for finding the area of the base shape. I've highlighted the base shape. It's a rectangle, hence the name rectangular prism. I can break down this formula a little bit more because to find the area of a rectangle, you just multiply length times width, and then you multiply it by how tall it is. So in this case, 8 times 7 times 4, and I get 224 cubic inches. On this other one, I've got a smaller base, 3 by 5, so I'm going to enter into my formula 3 times 5, and then the height is 10. 3 times 5 times 10, 150 cubic feet. I'm going to move on to triangular prisms. Triangular prisms are very tricky for a lot of students, mainly because in a triangle, the students have a hard time finding where the base is and where the height is of the triangle itself. So a lot of times what I like to do is in any given picture, I mean these are all 3 triangular prisms, they're just twisted around in different views, but they're all the same, representing the same 3D figure. So what I like to do for many kids, I like to cover up the figure, all of the figure, except for the base. The base is the triangle. So if I'm only concentrating my focus on that triangle, it makes it a lot easier to complete this problem. So again, I'm going to multiply the area of the base, in this case it's that triangle, times how tall it is. Now this triangular prism is not sitting on its base. Again, that's another thing kids are getting confused about, students are getting confused about. This triangular prism is sitting on a rectangle, but that doesn't mean that the rectangle is the base. It's still the triangle that is the base shape. Now, when we break down this formula and we need to find the area of the triangle, we're going to use half times base times height, because that's the formula to find the area of the triangle. Kids are like, what's the base? What's the height? Well, right here in our picture is a right angle. The base and the height come together to form the right angle. So whatever 2 edges, whatever 2 lines are touching this right angle, that's going to be your base, that's going to be your height in every triangular prism, in every triangle. Here we've got 2 lines that are touching the right angle. Those 2 lines make the right angle a right angle. So that's going to be my base, that's going to be my height. This other line here, that's called the hypotenuse. When we find volume, we do not use that other number, that other edge. We just use the base and the height. Students have a really, really hard time finding that base and height. So if you just find the right angle, the 2 lines that come together to make that right angle, that's your base and your height. That's what you need for finding the area of the base. The other numbers we might use later, but when we just focus on the triangle itself, those are the only 2 numbers we need. Okay, so once we figure out, okay, that's my base and my height of my triangle, I can put it in my formula, half times base times height. Then I have to have the height of the prism itself. So the height of this prism, even though this prism is laying down, it's not sitting on its base. If I moved it so it was sitting on its base, it would be 15 inches tall. That's the height. But in this case, it's laying down, so it's this long line here, 15. So once I've identified all of my values, then I just plug it into my formula and calculate it out. It's very, very easy once you know what numbers you're dealing with. So in this case, my volume is going to be 600 cubic inches. Here, I've got more numbers than I need. They gave me too many numbers. So again, I have to really identify what's my base in general, a triangle. What's the baseline of my base shape? 3. What's the height? 4. And then what's the height of the entire prism itself? 8. I never use this number 5 in finding volume. I might use it when I find surface area, but not with volume. A lot of students also ask me, well, is the 3 the height or is the 4 the height? Is the 3 the base or the 4 the base? When we're multiplying numbers together, honestly, it doesn't matter. If you multiply 3 times 4, you get 12. If you multiply 4 times 3, you get 12. So the order in that regard isn't going to matter for these problems, as long as you realize that they're significant to what you need, then you've got it all. Back here, I've got another image, and it's got all the numbers we need plus an extra number, and we've got, this image isn't really see-through. I guess you can say these two images are more see-through. This one looks like a solid block of cheese or whatever you want to imagine this is. So sometimes when we can't see through it, it's harder for kids to really see all the sides and to really look at it. But this is still a triangular prism, and when my two lines come together, that's going to be my base and my height of my triangle, and then I just multiply by how tall it is. I don't need this number at all. So in this case, when I find my volume, I've got 480 cubic feet. All of those triangular prisms are what we call right triangular prisms because they're all made from right triangles. Here we've got an image. It's still a triangular prism, but it's not made from a right triangle. So again, that kind of throws kids off. They're like, oh my gosh, I don't know where my base is. I don't know where my height is. I still suggest when you're starting with a prism, start with the base. This is a triangular prism, so the base is a triangle. And we need to identify, okay, here I can tell a little bit better where my where my right angle comes together. That's my base and that's my height. Always, always, always in a triangle, look for that right angle. In this case, it's a dotted line, and it's visually showing you the right angle. So it's where those two lines touch, that's going to be my base, that's going to be my height. And then I need the height of the prism itself. So if I took this prism and sat it on its base, 10 would be how tall it is. So when I do half times base times height, that's the area of the triangle, times the height of the prism, 10, I'll get 120 cubic feet. All right, moving on to maybe a prism that we don't really see very often. This is a trapezoidal prism where we can still calculate the volume. We just need to know or remember back when we talked about trapezoids what the formula for finding the area of a trapezoid was. Because when finding volume, we need to multiply the area of the base times how tall it is. Luckily, this prism is actually sitting on its base, its trapezoid. So if I look at this part of my formula, this is actually how we calculate the area of a trapezoid. Half times height, and we're just looking at the trapezoid. Half times height times B1 plus B2. Base 1, base 2. I know that's hard to figure out, but if we look at this line here, 5 inches, if this is 5 inches, this is 5 inches. So if I do half times height times B1 plus B2, that takes care of the area of that trapezoid. Then to find volume, I just multiply by how tall the prism is. So once I've got all that, I can actually plug it into my calculator exactly like that. Exactly like that. Or I can use order of operations and do what's inside the innermost parentheses first, addition, then multiply again, and get 280 inches cubed. I really stress to all students to write down their formula, fill in the formula, then pick up your calculator and type everything in, then write down their answer with units. This helps because a lot of kids want to see the numbers and kind of hold everything in their head, and what's really important here is when you start typing things into your calculator, you're telling your calculator how you want it to calculate your information. So if you forget a set of parentheses, your calculator is going to follow order of operations. So if I forget to put a parentheses here or put parentheses at all here, then my calculator is going to do order of operations based on what I tell it. So that's why writing down and filling in your formula is so important now, so that when you pick up your calculator and you're entering in as you wrote it, it will be correct, and you won't be decimals off or place value 10 place values off. So that's really important. I stress that to all kids. Then we have this prism here. This is a hexagon base. Hexagonal prism is what we call it. So, okay, in all of the formulas that we learned for area, we did not learn how to find the area of a hexagon. Any figure that's any base shape that has 5 edges or more, we did not learn how to find the area of that. So how do you do it? Well, guess what? In this case, and in most cases, they will already give you the area of the base. So what this picture is telling us is, hey, the area of the base is already calculated. It's going to be 7 square centimeters. You can tell its area of the base because it already has units squared. If we think back to area is units squared. So they already did half of our problem for us. All we need to do is take what they did and move forward and find volume. So in this case, I've got 7 centimeters, that's my big B, times little h, the height of the prism. So 7 times 8 is 56, and now my units are cubed because I have cubic centimeters. Last shape we're going to talk about is cylinders. Cylinders deals with circles, got a circular base, so we'll have to really know and think back to our properties of circles. Circles have a diameter and a radius. When we find the area of a circle, we need to know the radius. So anytime that a problem gives me the diameter, I automatically write next to it what the radius will be. So if the diameter is 10, the radius is going to be 5. That helps me later on when I'm filling in my formula not to mistake it with 10, the radius with 10, because that's what the diameter is. So again, if you think back to the general formula for finding the volume of any prisms or cylinders, it's capital B times little h. Capital B stands for the area of the base shape, a circle. To find the area of a circle, we simply do pi r squared and then multiply by how tall it is. In this case, I'm multiplying, instead of pi, 3.14, radius was 5, squaring that and multiplying it by 15. And this last one here, I've got a cylinder, but it's not on its base. We just treat it the same way. Pi r squared h, fill it in, and I've got my answer. I hope this helped you find volume of cylinders and prisms.